of elevation. Angles of elevation, then again in a second here, angles of depression. I know that this is something that you guys did last year in geometry, and if you remember, this was the one time you actually physically did something in geometry besides your projects. That's when you guys used those clinometers with the protractor and the weighted string on a pencil or on a paperclip. Remember that?
Yeah.
That lesson itself, in doing that, is something that Seb and I wrote 12, 13 years ago for a class in college. We have not changed that lesson in the past 12, 13 years. It was the exact same thing that we presented to our professor as well as our classmates and stuff like that. We all did the same project. We still use the exact same diagrams and everything like that. Yeah, we did. Yeah? No, it wasn't A+. It was like a 37 out of 40, so there. Did you just, me?
No, I was kidding. You're teaching us.
I know. So, what I want you to think of for angle of elevation is, excuse me, angle of elevation is going to be what we call line of sight. Line of sight looking up. Okay? Line of sight looking up is angle of elevation. Line of sight is what your eye level is looking straight across along flat land, if you will. Pretty much. What I want you to remember is that your line, what's called line of sight, is technically always going to be parallel to the ground. Now, in that project that you guys did with the clinometers, where you had the line of sight looking up, measuring angles and stuff like that, you guys always had to compensate for your eye value off the floor. Now, depending upon the style problem, sometimes that does come into play, or sometimes they'll just say, hey, a shadow reaches the ground and has an angle of elevation of 37 degrees. That means it's on the ground with that elevation part to it. It gets to be pretty specific. It's very, very straightforward if this case does happen. Because if you remember from back then, you guys had to add in some height value to whatever your overall height for the object was. So this angle of elevation is the theta that's placed there looking up at an object. Excuse me. What's that?
He just gave us a speech about that.
Welcome to Tuesday. Now, angle of depression is a little bit different. Angle of depression, then,
Yeah, put Anna's face
Yes.
in there. That just looks evil.
Oh my gosh.
so he's a bad guy with a Fu Manchu. So, it's a good idea, but no.
Use someone else's
If she was in this class, you would.
Yeah, you're right.
Oh,
So, angle of depression is not to scale. It's still line of sight, but it's looking down. It's this angle here. Angle of depression is your line of sight looking down to an object. So it's coming off, you'll hear this term a lot, off the horizon. When you're looking towards the horizon, it means you're looking out of your line of sight. You're looking down off the horizon, looking down at an object. So it's this value here becomes the angle of depression. Now, one of the things I want you to recognize is that when you have angles of elevation and angles of depression, usually what you're measuring is going to be a vertical or a horizontal distance. It's very rare that you measure a diagonal distance because, I don't know, I'm sure most of you guys have used a thing called a tape measure before. If you take the tape measure out and you push it out past like 5 or 6 feet, what happens to the tape measure? It falls over. That's true. That could happen as well. Been there, done that. Now, what happens is that usually you're measuring this horizontal or vertical distance because technically you can take a tape measure and throw it on there. It won't be a big deal. But one thing I want you to see here is whatever your line of sight is, your height from your line of sight, this angle of depression is the same thing as the angle of elevation coming back towards it because of parallel lines and transversals. Oh yeah, an angle of depression is the exact same thing as the angle of elevation. Yeah.
So like going back to like the eyeballs or to just the...
Yeah, go back to your eyeballs.
Okay.
Because what happens here is you've got two parallel lines cut by a transversal, and you get alternate interior angles. So that's what that happens. So a lot of times, you won't set up to solve an angle of depression problem by this imaginary horizontal line. You're going to flip it and place it back on an actual walking solid surface, if that makes sense. Yes, sir.
So they could do it. It's like okay, it's like the altitude angles, right?
Maybe. Yes. I'm sorry, she was talking. I didn't mean to be interrupted ever so rudely.
Good job, Bruce.
5 red pens.
It's
5 red
so
pens.
the things they can do is like altitude angles, right?
Yeah, those are just off the table. Yeah. Yep, that's how those things work. So, what happens then is that we can actually go through and, excuse me, and work through some very simple word problems.
Is that what you posted on class or the...
Yeah, I had a couple of different ones. This is different than the one I was looking at, though.
You had like 3 PDFs on there and one of them was the actual book.
Yeah, I know. There's different ones. This is what I want. For example, yeah, the ones I put on the website, I actually changed it just a little bit, and I think I put in the message part now which ones to specifically use.
You said like something that started with a K.
The CUDA, yeah. And I actually ran those off for you guys. I just had them on there in case someone was gone. So what I want to do here is look at one like this, and this is a very basic original setup so you know how this stuff works. And I know, like I said, you guys have done this before, so it's not going to be anything too out of the extraordinary. But you went to Paris to go see the Eiffel Tower.
Oh, wow. You can stop that if you can.
No. En français. Mais you go to Paris, you walk around the Champs-Élysées to the Louvre. And then you walk towards the Eiffel Tower, it's beautiful. And you have a baguette.
Yes! My cousin went to France and they actually took the tower.
So, hey, is anybody really, really cool like me and actually have been up the Eiffel Tower?
I've never been out of the country.
I'm sorry. Well, then you're cool like me because you've been there. So, we're awesome. The rest of you guys can suck it.
I've been there. I didn't have to one of your towers.
You've been there?
I've been there.
Alright, so here's what happens. You have a distance walked out from the base of the Eiffel Tower. Let's see if I can draw it.
Come on, you expert, you've been in it, you should know exactly the dimensions.
It kind of looks like
That looks like a rocket.
Okay, mister, I've never been to even
It looks like
anywhere.
a vacuum cleaner on a chair.
It does. It does. Here's the handle. Here's the cord. Here's the little light at the top. You know.
What does it look like?
A vacuum cleaner on a chair.
Because back in
All right. It says the angle of elevation from a point 116 meters from the base of the Eiffel Tower. Of course, it's in meters because it's in Europe. Losers. And then it says the angle of elevation from the base going up to it is 68.9.
What do you just use the
I don't know, because I am not American. I don't understand these things you talk about, because I'm French.
So why are you speaking English?
Because my English in French is not so good. Oh, top travel tip. I told this the second hour just in case you do ever venture out of the country and you wind up in France. As many of you may know, the French used to not like us a lot. They still like us a lot. So, you may, this is a top tip. If, by chance, you decide you want to travel outside the country, one way to get away from being that crazy, annoying American is to say you're from Canada, eh? So every once in a while when you talk, you just throw a little bit of a draw, and then you say, hey, every once in a while, eh? And then they think you're Canadian, and then you're just fine. Then you'll be like, oh, they're not a crazy American, they're a crazy Canuck. That's what they call them. So then they'll be fine. Or another way to get away around this, and this does happen, this does work. If you carry a backpack, which most people do when they're in Europe because you've got stuff and things, put a maple leaf on your backpack. I'm not lying. By putting that on there, it says you are not American, you are Canadian. Eh? Word up, hoser. That's how they talk. You're a hoser. It's like, you're my friend, you're my hoser. You don't care. I'm making jokes. Nobody cares. It's true, I have. None of this, and guys, your mom's cool. So, that's not nice to say your mom. So, and then brings up, this is, you know how I say this whole 85-15% stuff? This is the 85% truth, because I have been there and I did this, and it kind of helped.
You did this, Canadian? Did they really not?
Hey! What's up there, eh? Yes, sir.
Like a couple of years when we went to Iceland, everyone there actually hated us. It was obvious that we were like American tourists and stuff, and everyone was really rude on us.
So that's why you just talk to me once in a while with a little bit of an A, and then say, oh, where are you from? I'm from Manitowoc, and then you'll be fine.
No, in European country, like Ontario.
Oh, I'm from Ontario, eh? So, isn't Ontario the one they speak French, though? Then they're going to want you to speak French. So that's why you say something else.
I'm from Vancouver.
Hey, so what trig function are you going to use?
Yes. If you say it like that,
Obviously, in this case, you're solving for the overall height, so this isn't anything crazy. You just multiply both sides by the 116. And that gives you something in meters. Once again, it's European. I don't understand this whole metric system. It's about 3 seconds slower to swim 100 meters than it is to swim 100 yards. That's all I can tell you.
It's about
over who? Like a good swimmer?
Yeah, it's just on normal. It's usually right in that neighborhood, 2-3 seconds. All right. Got another one. We make this more difficult though.
That's like 300 and 200.
Yeah, it's a little over 300 some odd meters, so
It's
it's
like 0.62.
yeah, so it's about 900 feet, 950 feet or so. That's about right.
And you want us to go 2 places?
Yeah, I usually go 2 places. It's fine. Now,
Have you ever been to Ireland?
no, everybody in my whole family's been there but me. Anyway, just put your excuse me.
Just put your coat of arms in your backpack and you go down.
That's what all I need to do. Excuse me. So a backpacker notes that for a certain point on level ground, it's helpful, that the angle of elevation to a point on top of a tree is 34 degrees. After walking 50 feet closer to the tree, the backpacker notes that the angle of elevation is now changed to 54 degrees. Makes sense as you get closer to something, it's okay. So we need to find the height of the tree. Now, this is the style of problem that you will start to see more of in an Algebra 2 course as opposed to, oh, look at the beautiful Eiffel Tower. Those type of problems. Those are too easy. These make you think. So, What is the one thing that makes life easier with trigonometry word problems?
Calculators.
Pictures, calculators. So what do we need to draw? A tree.
Yay! Draw a line. You've got to give it a little tree friend.
Happy tree friends?
A happy tree friend. Yes!
We were on the tree. It was like right before.
A tree.
You want to stop though.
I bet I can do better.
Level ground.
Wow.
Are you sure?
It kind of goes.
Is this what you're using X and stuff?
The what?
Give you a point. You're killing me.
Not. I don't know. I'll show you here.
Is the fact
That's
that
at a certain point on the
Guys.
they're a backpacker supposed to give more credibility or something?
I didn't have a backpacker, but I had a man with an axe. So, what this guy's doing? Shh. Now he is a backpacker. He just don't see it. He's got a real small backpack. But what he's doing is he's carrying his axe to go to the tree to carve his initials and his love's initials in the tree to make himself.
Feel wholesome.
Oh, yeah, something. So, the angle of elevation.
I don't even really want to know. Okay, so this isn't from his eyes.
No, it's just, yes, from the ground. He fell over. He was taking a nap. What's 34 degrees? Okay. At this point, how far away is he from the tree? X. What should we call the height of the tree?
Why?
H for height.
Wow, that's cute.
Because we don't know what that is, so we might as well call it.
Call the hypotenuse.
Anyway, he walks 50 feet closer.
X minus 50.
The new elevation was at 54 degrees,
Yes.
and then this is X minus 50. Apparently the guy with the axe is coming after him.
This is what we use for
No.
So I
What-
made an axe with
Guys, what happens here? What's up? We've missed you. What I want you to see here is that you actually wind up with two separate trig functions that you can write out. We have one of them from the 34 degree angle. The tangent of 34 is your height over x. We okay with that? If you move to the other position, you have the tangent of 54 is the height over x minus 50. Okay. Now, between those two separate trig functions, you'll notice that you have an h in both of them. So what we want to do, what's that? No. What I want to do is I want to manipulate both of those two equations to get h by itself. That way I can use substitution. Yep. So what happens is this. We have the tangent of 34 was x over h. Oh, I'm sorry, h over x, excuse me. And then the other one was the tangent of 54 was h over x minus 50. Was it 38 or? It was 34. Okay. So, equation on the left-hand side, how do I get h by itself? Multiply out the x, just bring the x over. Yeah. You can do this one of two different ways. If I do the same thing on the other one, I can say that x minus 50 times the tangent of 54 is also h. Are we okay with that? Now, Hoppenworth, what you were saying is just to take this immediately and just put it up here. It's fine, you can go that route as well. I'm going to show why these numbers work, why it works out. Tangent of 34 is just some crummy decimal. Do you agree?
Yes.
Do you think maybe the tangent of 54 is also some crummy decimal?
Possibly.
All right, so don't even worry about it. Just know that you're going to press a button in your calculator at some point in time to figure that out. So what I would do is just set them equal to each other. Because they both equal h, I can set them equal to each other. Okay. Now, what I want to do next is probably the easier of the two steps. I'm going to divide both sides by the tangent of 54, okay, instead of distributing, all right? Because if I divide this side by the tangent of 54, and I divide this side by the tangent of 54, I'm going to get some crummy decimal times x, some decimal number, equals x minus 50. Are we okay with that? All right. Calculator. Go to the calculator and let's type in, make sure you are in degree mode. Always make sure you're in degree mode when you start these problems up, just in case something happened, especially you, Lamont. No offense. It's just that yours has batteries and we don't know if you dropped yours. Or Sadie took a battery just to mess with you. Because she probably would do that.
Yeah, that's very true.
That's very true. So when you type in tangent of 34, make sure you close your parentheses and then divide by tangent of 54. If you don't close the parentheses, you're going to divide, excuse me, you wind up dividing out 34 by a tangent of some other number. It's just going to mess everything up. So I get this crummy decimal times x. You okay with that?
Yep.
Okay. Now, what I want you to think of, I'm just going to move this off to the side for right now. We have some decimal, we'll just say 0.49. I think we'll be okay just by rounding that out because it goes 0.005. So we're going to say right now we have 0.49x equals x minus 50. Variables on both sides of the equation. What do you do? Do I just move this here and move that there?
Yep.
So I get 50 is 0.51x.
Wait, what?
What's 1 minus 0.49?
Very clever, Mr. Murphy.
That's 1x, isn't it?
Yeah.
So if I subtract 0.49x,
Oh, okay, I see what you're doing. I got mixed up with 50 because like I thought you looked at 50.
oh yeah, I moved the 50 over by adding it back. So now all I have to do is take 50 and divide it by 0.51. What do you get?
98.4.
All right, so I get 98 point what? 04. Now, is that the height of the tree or the horizontal run? That's the horizontal run. So if that's the horizontal run, then what do you have to do to figure out the height of the tree? Well, exactly. You now know one of the values of x to put back into the other. Yes, ma'am? I don't. If you want to run the rest from your guys' we would have to help yourself. Okay? So you wind up with something that kind of looks like it'd be awful, but as you start to piece it together, knowing that you're in two different positions, looking at the same object, you're just using that same piece twice to solve it out. You're solving a system of equations here, technically, with trig functions. Yeah?
Basically, x, you just, let's do x and you just subtract 50. The x minus 50.
Oh! Excuse me. Always go back to your originals. Because up here we had that stuff. Because you still have to find the height. So if you take this value of x, subtract 50, you still have to use it to find the height. So when I go back here, remember how we had the height was equal to x times the tangent of 34? You substitute in there and that should give you the right value. If you go either way, it should be pretty darn close within a couple of decimal points. And that's how you get your height. Is that terrible?
Yes.
Shut up.
Yes.
You'll get over it, right?
Probably not.
Just remember about being Canadian and be fine.
Alright.
The height
Now I'll see this one.
So what was the height?
Oh, what was it?
66.13.
There you go. So the tree was
13.
66 point what?
13.
And the overall distance was 98 in something. So this overall height was 98.04, which meant this height here, this distance here was 48.04.
Wow, I got 145 for the height.
One in the back.
98.04 times tangent of 34?
No, I'm not.
Just put it in the
Oh, I know what I'm doing.
What'd you do?
Oh, I put it in for 8 instead of X.
put it out.
And that's the idea. You gotta make sure you know which ones you're solved for. Let's just name them through.
Well, it's not like I knew. I just kept like plugging in the wrong hand. I'm like, why is it not working?
It's like beating a dead horse. Why aren't you working? So, axe murderer.
Axe murderer. It went from backpacker to axe murderer.
You know, we changed things up.
Same difference.
Backpackers are just as easy.
Alright. Remember yesterday I also told you guys that we're going to be doing stuff like this, where you could be given a specific trig ratio, and then you have to find another one. What's that? What are you flipping? Okay, rephrase that. Cosecant, if you flip cosecant, what are you going to get? Sine. Okay. Remember, when you're dealing with your trig functions, you have sine, cosine, and tangent. Cosecant, cosecant, secant, cotangent. Now, if sine is what over what?
Opposite over hypotenuse.
Cosine is
Adjacent over hypotenuse.
Opposite over adjacent.
so that means you flip these around, you get thanks for keeping. So in this case, cosecant in a right triangle is your hypotenuse over your opposite. Which means you have to figure out, well, first of all, you know where your right angle is. You know that 17 has to be the hypotenuse. Now, does it matter which of the other two angles you place theta? No, it doesn't make a difference because trigonometry is all about perspective. It's all about where you are in relationship in the between the angles themselves. So if I'm down here at theta, my opposite is 15. If I'm up here at theta, my opposite is still 15. It does not matter. That's why when we talk about trig is always about perspective of where theta is placed within the triangle. As we build up further and further into this stuff, where theta becomes placed does become a little bit more important because it kind of has to be placed in the same spot. But we'll talk about that later. Now, here, if I go back and I say, here's my opposite, what am I missing? I can do Pythagorean theorem, or do I recognize this?
Oh, it's 8.
It's very good. It's 8. It's a triple.
Yeah,
Now, if you forget your triples, your triples for 3, 4, 5 is the most common. 5, 12, 13, 8, 15, 17, 7, 24, 25, 9, 40, 41.
Remember 3, 4, 5.
And then I'm done. There's a way to actually create your own triples, and I figured that out once and I forgot. So, thanks. So now, if I want to figure out what the tangent of this theta value is, its tangent is what over what?
Opposite over adjacent.
So it is? Because it couldn't get away from the theta. Okay. And then, what's that?
The joke is really wrong. I just got
I've had this question asked of me quite a bit. What happens if it gives you the cosecant of something is just 3? What is cosecant again? Very good. Because cosecant is what over what? It's hypotenuse over opposite, which means they are just saving ink by not putting this over 1. So if you place your theta, hypotenuse is 3, opposite is 1. What am I missing for the other side? A number. Very good. Well, what's 3 squared? You're missing 3 squared is?
9.
What's 1 squared? What's 9 minus
Square root of 8.
1?
8.
Square root of 8. So what's the square root of 8?
It was
2 root 2. Very good. So if theta has an adjacent now of 2 root 2, secant is the inverse of excuse me, cosine. Cosine would be adjacent over hypotenuse. Secant would be hypotenuse over adjacent. So you get the secant of theta would be 3 over 2 root 2. But what do you have to do? Very good. Multiply top and bottom by the root 2's. And you get 3 root 2 over 4.
Oh, yeah.
But we always simplify radicals. Always simplify radicals. Okay? Terrible?
No.
So I made a, instead of having you guys try to go back and forth on the book site, because it can get kind of a pain, I just kind of ran off some questions. Now, we're not doing all of this. Actually, probably get rid of one of the pages, but that's still thank God.
Seriously, I swear she's young thing, John. This? I don't know.
I have so many. Oh, great. Oh, no.
Staples my pencil. Huh?
Guess we don't have to do it.
What's that?
We don't have to do it. Oh, the one I saw
Oh, it's working its way up.
page 1. I ran out of reason.
No, it's fine.
It's fine. Yeah, which is it? I just was it this page?
If you were reading a book, what would be page number 1?
The first one.
Wait, so it's this? It depends on.
So what would be the second page?
On the back.
That's so many. That's so many.
You have to do page 1.
Yes, you'll be fine.
Can we write the answers down with
You'll probably want to do the work on another sheet. I just put them all on one sheet, and I thought about doing extra ones of these, but then I realized that these are too easy. So if you want to do this and get rid of page 3 and 4 and recycle it, that's fine. What's that? I don't know. You might. I don't know. So basically, you're just working with it first, front, and back. Okay? You're going to want to draw these on a separate sheet of paper so you have space.